Hello, this video is to show how to use STAAD to model truss. And this is today's example, and we will find the member force in this wooden truss. And this wooden truss has a pinned support at A and roller support at E, subject to 3 nodal load, 600 Newton at B, 800 Newton at C, and 600 Newton at D. And today, we'll use that to find the member force in all those truss members. First, open the software, STAAD, and you enter this interface. And then we hit Configure to set up the base unit. And for this model, we have the Newton. We have the Newton and the meter, so it should be a metric. Set metric and leave everything default and click OK. And then go to a new model. Then enter the model information. And I just put the truss 1 as a file name and location. Select a folder to save your model file. And then check the type of file is analytical and unit is metric. So all match our model. And go down to the job information. And for the job name, I just put this STAAD session 3. Truss modeling. And today's example is wood truss. Client, I put RIT, and job number is the course number. Leave revision parts empty, and reference is the class example hand calculations. For the truss. And name, enter your name here. And the date. Comment, and we will use STAAD to model a truss. And the purpose of this example is to check the member force in each truss member. And compare the results with hand calculations. Okay, after that, click Create. After Create, we enter this analytical modeling window. And in this window, we will do the input in the order of geometry, properties, materials, specifications, supports, loading, and analysis. We'll end at analysis. Okay. First, we'll do the geometry input. And before we do that, we need to double check the unit. You go to the right bottom corner right here, and it shows the input unit currently is set as kilonewton meter. But our model is Newton meter. So we need to change our input unit by using this button. It's called input unit. Hit that and use metric. Okay, for the metric input unit metric, enter the metric. Select the meter and Newton. and hit apply. Okay, then double check the unit. The input unit should change to Newton meter. Okay, so now I start to input the coordinate of each node. And for this example, we have 8 nodes, okay, 8 nodes, and we manually input those 8 nodes coordinates. Okay, so we have 1, 0, 0, 0, node 2, 2, 0, 0, 3, 4, 0, 0, 4, 6, 0, 0, 5, 8, 0, 0, 6, 6, 2, 0, 7 is 4, 2, 0, and 8 is 2, 2, 0. And we do the input in this order. Okay. Okay, so now we get all those 8 nodes input. Okay, and you should see the nodes show on the screen. And since this is a 2D model, the 2D truss, I want to see just XY plane. So go to view and change the view to XY plane. So we hit this front view button. And now you can see, we just see the XY plane. Okay, so after you input the nodes, we need to draw the beam members. So back to geometry. And since this model has 8 nodes and also have multiple members, and it's good to show the node numbers and beam numbers. Okay, so what I will do is put your mouse anywhere in the screen, right click, then go down to labels, then check node numbers, node points, and beam numbers, and then click OK. And you should see the location of each node as well as the node numbers. And when we draw the beams, you also need to also see the beam numbers. In that case, we can easily keep a track. Okay. Then we use this Add Beam button, okay, to draw the truss members. Add Beam button. So we start to draw 1 to 2, 2 to 3, 3 to 4, 4 to 5. And we draw the bottom chord already. And then we will draw the top chord. Okay, so I will start from 1 to 8, and then 8 to 7, 7 to 6, and 6 to 5. And after that, I will draw the vertical members from 2 to 8, 3 to 7, 4 to 6. And last, draw the diagonals from 2 to 7 and 7 to 4. So now we're done with geometry. Draw all the beam members. You can take a look, just compare with geometry with the original model. So we're done with the drawing part. And hit escape. Okay, so done with geometry. Save your model frequently. And go to properties. And for the properties, this example, we want to use glued laminated timber. It's a wood truss. So for the properties, we will select the timber properties. Okay. So this one, we have glued laminated timber. the section size is 0.2 meter by 0.2 meters. So go to section database. And this section profile table pop up. And this time we'll use timber section. Okay, so we use timber section. And under this timber, there's a list of different type of timber. Okay, and today we use glued laminated timber. Use the top one. Okay, so select this one, and we just use the first in this list. Okay, select that. Select the glued laminated material. We just use the GLT 16F. Use that, and then input the section dimension. YD is the depth, so we put 0.2 meters. And ZD is the width, so we put 0.2 meters for section. Okay, and then we don't change anything for density. Okay, and just do add. And now you can see, okay, you can see this, the section property show in this property window. And just close that. And now highlight this section. Okay, so highlight this section and use assign to view. So this truss has multiple members, and we want every truss has this section property. Okay, so assign to view and click assign and click yes. Okay, so now you can see all the members has this R1 section property, and which is the glued laminated timber. The section dimension is 0.2 meter by 0.2 meter. Okay, so now we're done with section properties. All the members has this timber properties, and then move to materials. Since we already assigned the timber material, the program should automatically set the timber material to each member. Okay, we just double check. Okay, and we double check here, and looks good. Every member has the timber material. Okay, and we just go to the right. Okay, specifications. And for specifications, for truss model, we use the specifications to assign all the members to be truss member. In order to do that, we use the beam button right here. And under this member specification, we'll use the truss option. Okay, so we'll use this truss option and then do add. And you can see here member truss. And after that, highlight the member truss and assign to view. Because all those members now currently in the screen are truss members. That's for truss modeling. Make sure that you use specifications and member truss assigned to any members that is a truss member. For this model, all the members are truss members. Truss members means that every node is pinned connected and only subject to nodal load. Okay, so now we use assign to view and click assign and just yes. And now you can see all those members have this truss specification. Okay, so now we're done with specification for this truss model. And go to the support. And for this example, we have two supports. A pinned support at A and roller support at B at E. Okay, so now we need to create these two supports. So we create first do a pinned support. We just select this pinned support from the the window. Okay, so just add and then create a roller support by using fixed but. And roller support will release Fx and Mz and do add. Okay, so after that, we assign this pin support to node A. Use cursor to assign and assign to node 1 and escape. And then highlight the roller support and use cursor to assign and assign to node 5 and escape. So now we're done with the support. Okay, and go to the right one, loading. And for this example, we have 3 nodal load, 600 Newton at node 2, 800 Newton at node 3, and 600 Newton at node 4. And for truss model, all the loads are nodal loads. So first, we do a load case details to add a load case. Okay, so hit that load case details and add. And for this example, we just use a dead load case and put the title dead load and do add. And you should see the dead load under the load case details. And we just do one load case and close. And after that, highlight the dead load and add load items and do add. And then we need to add the nodal load. Remember, for truss model, only subject to nodal load, the load at node. Okay, so we just highlight this nodal load and choose node. And the first is negative 600 Newton. And this negative 600 means downward direction in the y direction. And this 600 is at node 2 and node 4. Okay, so first we need to define that, just to do add, and you see that Fy negative 600. Then we change that to 800. Okay, negative 800 also in the y direction, and do add again. And now see the nodal load Fy negative 800 Newton. Okay, so we just have these two definitions, and we will assign those nodal load to the node 2, node 3, and node 4 respectively. Okay, just to close that and highlight Fy negative 600 Newton and use cursor to assign and click assign to node 2 and node 4 and escape. And then highlight this 800 Newton load and use cursor to assign and assign to node 3. Okay, and escape. So now we are already done with the loading. It's just a 3 nodal load. And then just save your model. Okay. And then move to the right, analysis. So for this analysis window pop up, and we use define command. And for this one, we just choose the first one, no print, and do add. And we should see this perform analysis command show up in the window and close. Then the last step is post analysis command. And this is the place to define the output. Okay, so we hit post analysis command to define the output. And for this window, we use define command. And for define command, Truss, we want to find the Truss member force. Okay, so for the output, we'll use the maximum force, this option, maximum force. Choose maximum force, and output will give you the member force in each member. Choose maximum force and do add. And close. After that, you should see this print maximum force envelope. Okay, and with question mark, and we need to tell the program that which member that you want the output. So we highlight this print maximum force envelope, and for this example, I use assign to view, okay, because I want the member force in any of those members. So I just assign to view and click assign. And now in output file, it will show all the member force in this truss. Okay. And now I just save my model and run analysis. You should target at 0 errors. Okay, so we can neglect any warnings from this program, and then just hit this view output file and done. So it will show the output file, and for the output file, we can click this results maximum envelope. Okay, so to double click that, and you can see the member force in each member of the truss. Okay, so you can see those member force, and we will target at this Fx, and Fx means for this member force follows the local axis, local direction. So x local direction means is axial load. X local means axial load, and for this Fx, is give you the number, the magnitude, as well as either in tension or compression. So the tension represents with T, and compression represents C. Okay, and those are member number. For example, member 1, we have 1,000 Newton tension. So we can take a look at member 1 is this member. Okay, so 1,000 Newton tension. And member 5, for example, is 14 compression. Okay, so we can go to the model. Member 5 is a compression. Okay, so 14. Okay, so after that, we can just print output file into a PDF. Okay. For example, I just called the Truss one output file. And now you can see the output file. And the member force, we target Fx right here. Okay, so we target that. And this is the member number and the load. Okay, so you can compare with your hand calculations and refer to the member numbers and compare each of the force. And after we compare that with our hand calculations, we can confirm that all those member force match our hand calculation. Okay. Okay, so we're done with this example.